Awesome presentation. Thank you very much. But let's move further. Let me introduce Mr. Peter Vesilak from CLAB company with great topic. Merito measurement and analysis of consumption in real time. Not an easy one. I'm sure he will elaborate. But prior elaborating, I will introduce him further. Peter is an associate professor at the Faculty of Electronics, Engineering and Informatics, Technical University in Košice, mainly focusing on communication and infrastructure. He will lead us through and elaborate on topics like Merito, today's 15 minutes performance, 5 measurements up to real-time level. Prior moving forward, let me ask you a question, of course. Why have you decided to establish or to create a startup?
Thank you for the question, as well as for inviting me for a presentation for such a great event. Let me answer that in a way like I was working on different research projects at the Technical University more over the decade. And we've been always faced to the lack of the feedback from real customers. So we designed solutions which were progressive with the problem of a long time delivery to the market. So this is especially true when you are working with the students. And therefore we decided to establish the startup in order to transfer some of the research results which we had into a product which would be available to real customers, and through that we would be able to get a real feedback.
Thank you very much. Handing over to you, you can proceed with your presentation.
Thank you very much. So, dear ladies and gentlemen, it is my great pleasure to share with you what we are doing at the CEE Labs, the university startup, and the product called Merito, which is supporting the monitoring and the power consumption analytics in a real time. Before I'll go with the technical details, I will briefly overview you with our team. Most of our employees are the university graduates or the PhD researchers. We all had a passion for technology and innovations. Our professional background is in a computer networking and the cloud technologies. And one day we decided to change the world of the energies, the world of Internet of Energies. So here we started to focus on a problem of a high energy inefficiency and simply dealing with how much energy is being wasted in different types of buildings. And this may be especially true for some university areas or secondary schools and so on and so forth. So we started to focus on the standby consumption. And let me tell you that while the residential customer is able to save about 60 euro per year, when we are thinking of a little bigger environments, the company campus or the city hall of Košice, for example, which is depicted on the picture, here we can save about 40,000 up to 60,000 euro per year just in a standby consumption. And the problem of a high energy and efficiency linked with the standby consumption is not only the problem of manufacturing, the cities, the governmental organizations, schools, but basically of all of the institutions where the residential customer is not feeling responsibility for the energy management. And usually it is due to the fact that the residential customer in such a building is usually not the one who pays the bill, right? So with that, we were thinking about providing better tools for energy management. And let me tell you that while we've been talking to many facility managers, we identified that there is really a lack for such a data and tools. So to properly understand where is the root cause of the energy wasting. We created a solution which we call the digital energy officer of a managed objects. And that's basically a technology which is installed in a wiring closet together with the cloud-based software, which is using some AI algorithms in order to provide in-depth data about where, when, and actually also by what is energy being consumed. Just after you would have a proper understanding of your internal environment, then you can also reduce the carbon footprint in a controlled way and simply also to save some money. So this is a technology that really helps to cost savings. First of all, our technology called Merito. So therefore the presentation is called like the Merito, the analytical tools. The Merito is kind of unique when compared to the other power consumption meters, where we are usually having 15-minute load profiles. We created the technology that is providing a 50 millisecond samples in a cloud for data processing. So the key in our technology is really in granularity. And this is something like it is really suitable for a machine learning algorithms in order to identify or deeper, provide the deeper data from the environment where you are operating such a metering system. So here with such granularity, we can create something like fingerprints of every single electrical equipment or device which is being operated inside of your building or a household, and recognize the individual equipment as it is being operated inside of a monitored building. I used to say that we are like a Shazam in electrical wiring. If you know such a service, which is helping you to recognize the song you are listening to by some patterns, we are using something very similar. So we are able to recognize the device as it is operated in the building by the patterns. And with that, we know when the device has been turned on, if it has been turned off, or maybe the more important thing is if it remained on somewhere where it is unseen by the people. And that's where you are able to then allocate the particular equipment and save some money also from its operation. Currently, we are in an MVP state. It is a certified solution, and we have more than 300 pilot installations. From a technical perspective, it is a single point and a three-phase, four-quadrant real-time metering system. And on the right side, you can see some of the installations. So this can be installed, for example, next to the power meter somewhere outside at the pillar mount wiring closet, or it can be installed somewhere inside of the building. Of course, in a wiring closets. From a technical perspective, it is the semi-direct and a non-invasive method. So we are actively monitoring the voltage, and passively using a split core transformers, we are measuring the current. From a perspective of accuracy, we are reaching up to 1% on an active power, and with that linked also the active energy. From a perspective of communication and connection up to the cloud, we are using an 802.11 Wi-Fi interface, which connects to the local infrastructure in your building, or if it is installed in a household, then it connects to the local access point. And we are also supporting the LoRaWAN technology. Those of you who know, the LoRa is for a long distance radio. And basically, there is one small limitation from the perspective of amount of data which you are able to transmit over the time. So with that, it is very easily usable in a large area where you need to cover some kind of metering. But from a perspective of analytics, it is really better to use the typical 802.11 for real-time communication. But I understand that in some of the cases when the area is kind of large, it may be really difficult to build up an Wi-Fi infrastructure. And regarding the new technology, and I'm sure that you listen also to a number of topics which has been presented also within this conference. Trendy is 5G. So from a perspective of a modular architecture, we are also a 5G ready right now. We do have also an RS485 interface, which allows you to connect to bus devices on this interface. Typically, you can do a remote readouts from power meters, for example, to get also the billing data. Or you can connect that with the local devices, which allows you to maybe more effectively manage the consumption of the energy based on the currently measured data. And this is especially useful, for example, in a photovoltaic systems. So in case that I'm producing and feeding the network with the produced energy, I'm maybe also consuming that just by turning on some equipment which is already laying somewhere at my house or at the building and could be used for that purpose. Once the installation is done, we do have also a cloud interface, and finally also the user interface, which allows the user to manage all of the devices which are installed inside of the building. This is done in a kind of a hierarchy, so you can structure that in a way like these are the floors, these are the offices at that floor, and so on and so forth. And after that, you can review the data in a real time. This can be, of course, from the individual points of metering, as well as you can do that from on the top of the groups. So like I'm interested in how much power we need at the moment for a particular floor or the office, and so on and so forth. So within the user interface, we do have an environment where you can review also the historical data. And even when I mentioned that the key factor of a Merito technology is the granularity, here we are using the granular data, like the second or sub-second data, just for the purpose of automatic recognition. But from the perspective of historical data, it is usually enough to have a 1 minute averages or hour averages. You can, of course, go into a detail and review what exactly happened at a particular moment of your interest. From a perspective of analytical tools, the bigger institutions used to monitor the maximums in 15 minutes, of course, maybe the hour averages and overall consumption split into, for example, weeks or the months. I already said that this is kind of a special device which allows for recognition of the equipment. And with that, you can monitor the operation. So for example, when the fridge was turning on and turning off a compression engine, or moreover, if there is maybe a problem linked to that, so it remained on and has not been turned off, or maybe I left the doors open on a kitchen fridge, and so on and so forth. So this is what you can monitor from recognition of individual devices. And of course, you can mark that down, for example, into a profile, power profile, where you can indicate when actually at the particular moment the device was turned on, or later on it finished its operation, like, I don't know, the washing machine, for example. At the end, we are having also an integration, or the possibility to integrate with the third-party systems. We are providing an APIs in order to use the real-time data as well as the historical data for the further processing. Here, for example, one of the great examples, and you can see that, by the way, in University Science Park at Technikum Košice. So you are very welcome if you want to see that in a real action. And there's augmented reality, for example, which is showing you while you are walking over the floor, what is the actual consumption of every single office on the floor. So that's like an integration with this particular technology. Let me tell you a little bit more about how it is built. So what's the structure behind and how we are providing this architecture. There are 4 pillars, and it's an access layer starting from the bottom, then the secure transport layer, the cloud processing layer, and finally an application layer. At the lowest level, there's an access from Merito base, which is like a base device to meter the data and to provide the granularity of measured parameters. So it is exporting that every second or less than second to the cloud. And there is a secondary device at the bottom layer called Merito Controller, which allows you to utilize the data provided and do some action. So for example, if I'm running out of the profile, I can turn off something which is not really important at the moment. Or as I already mentioned, for example, if it is linked with the solar panels, you can, for example, turn on something based on rules for utilization of the energy. Then we are having a secure transport layer, which is like an entry point somewhere to the cloud. And therefore, we are using a load balancer for the purpose of loading the balance, of course, or balancing the load for multiple devices. We are having here a message broker, which collects the data, and then some device orchestration. As I already said, our professional background is mostly in a computer networking, so all of the security features at the background are incorporated in a product. So it is changing some security tokens in order to securely deliver the data to the cloud, as well as later on to allow the users to access them. Then we are having a third layer, which is a cloud processing layer. Here we are having some data processing middleware, which is basically software which is doing some pre-processing of the data. For example, doing 1 minute averages, hour averages, and so on and so forth. And those are stored in a data storage. Later on, from a data storage, they are accessible through the different backend services. And that's like, again, entry point for an application layer. In an application layer, we are using different data analytics tools. So those are, for example, monitoring the maximum reserve capacity and notifying the customer in case of crossing the threshold and so on and so forth. We are having an automated reporting and visualization. So this goes through different channels, like you are receiving the notification over the email, over the SMS, over the WebEx Teams, and so on and so forth. And of course, some user interface, which allows you to review all of those meter data in a basically real time. Again, from a technical perspective, if we are planning the installation somewhere, we are using an passive transformers. We used to use the YHDC transformers. So there is a strong portfolio of the product available, of a different rated inputs, of a different wire diameters. But usually we are going from 25 amps up to 600 amps. And if we need to monitor maybe higher currents, then we are using Rogowski coils, and those goes up to 1,500 amperes. Let me tell you maybe a little bit more about also about the recognition of the equipment and how we are processing the data in a cloud. So we are coming a little bit more into a machine learning. As I already mentioned, we are exporting something about the 20 samples per second into a cloud for data analytics. So this allows us to identify the rising shapes and the falling shapes of every single equipment which we are turning on or turning off. On the background, we are typically doing 12,000 samples per second, like normal smart meters. Due to the sub-second data which we are having, the rising and the falling edges allows us to effectively recognize some of the equipment which is operated in your building. And the final thing which we are using is the PQ map, which is basically a map taking the data from active and a reactive power of a particular equipment. And you would see that a little later on how we are using that for grouping purposes. So as I already mentioned, we are capturing the 20 samples per second, which are in a cloud for data analytics. And here, for example, on this particular chart, you can see a couple of devices being recognized in a building, or that's particular from my household, for example. And some of the devices are turned on or turned off in a less than second. And that was also the key factor why we went to sub-second data, which we are providing. So once we are having rising shapes and the falling shapes, with that, we can effectively recognize the operation and the startup or turn off of the equipment. From a perspective of a PQ map, you can easily see that every single equipment is having its specific parameters, like what is the active power and the reactive power. And you can group multiple stages at the same group, right? So here, for example, you see that all of those green dots was the single equipment, just changing a little the active or reactive power. At the end, our goal is to do a cloud-based data analytics with the AI algorithms, right? So we are trying to recognize the equipment, mark it down in a chart, like when it has been turned on or turned off. We are able to provide you with a recommendation or a tip what kind of equipment it is. It is the load of I don't know, for example, the compression engine, or it behaves like a bulb or whatever else. So then you will need to name it, what kind of equipment it is. At the end, we learn also how your devices behave in time. And due to the fact that we see multiple activities inside of a single equipment in a very detailed manner, then we see also, for example, the washing machine in its details, like it is heating, it is twisting, it is filling in the water or putting it out or whatever. but from a perspective of a customer, you would be maybe looking for information about this was the washing machine. So with that, our granularity goes much deeper than the state of a maybe on-off single equipment. And with that, we are applying also the grouping algorithms, which are trying to find the patterns of or sequence of a similar activities and then grouping that back together. So we would be able to tell you this was the washing machine, even when it is heating, twisting, and filling in the water. At the end, what you would like to see is very likely a chart when we will split down the whole energy consumption of a managed object into a particular equipment. Here you see, for example, that everything is unknown, but it is up to the user to define what those unknowns are. Of course, you will need to maybe turn it on, see the notification, and then write down, okay, this was a heating kettle or whatever else. At the moment when you are able to recognize when the device was turned on or when it finished its operation, you can focus on the abnormal activity detection. So that's also one of the part of our product, Merito NML detection. And here we are focusing, for example, on a duration. So if the device was operated longer than normally, or it was kind of a very short activity, even when normally it is being on for a couple of minutes. And with that, we can notify you about falling equipment like the compression engine or whatever else is behaving abnormally from a perspective of a duration of its operation. Of course, we are watching also the occurrence over the given period. So for example, we are monitoring when you are using the particular device over the day, over the week, over the month, or over the year. Those green dots, for example, here represent the normal behavior. So you will put the system into a learning state. We'll do a normal actions. And then you are watching to anomalies. And the red dots indicates them. So once they will appear somewhere, we can notify again the user that there is something wrong with that particular device, or there is an anomaly from a perspective of a duration, the operation in a day, week, month, or year. And one of the things which might be usable is also the missing activity. So for example, the machine should be turned on automatically, but it didn't happen. So there is some fault in that. Okay, so I shared with you a lot of things from the inside, like how it is operated. At the end, let me just wrap up maybe where the product is usable. So we are focusing on 3 areas. Of course, the facility management, what I already mentioned. So whoever needs to know how its environment is behaving. And therefore, here we are hitting the manufacturing, the governmental organizations, and the city buildings, as well as grocery stores. The second part, which we are focusing on, and there is a separate track on that, is in education. So we have a couple of secondary vocational schools which are learning on how to use the APIs and then to post-process the data in order to better understand the value of the energy they are consuming at the school. And finally, also the residential customers. So these are the 3 segments where we are focusing on. Okay, so that's it about the Merito technology, the technology that supports the monitoring and the power consumption analytics in a real time. I'm very thankful for this opportunity. Let me thank you also for watching to this presentation. And if you will have any questions, I'll be glad to answer them. Feel free to reach us at info@ceelabs.com. Thank you.